The youngest members of the human family haven't yet begun thinking of what their energy needs will be in the coming decades. But others have. Almost everywhere we go and everything we do, the economy and our way of life, has been made possible by decades of accessible, affordable power. The price? Pollution and climate change. The ultimate goal must be to stabilize the atmosphere. But it won't happen overnight. And in the years ahead, worldwide demand for energy will dramatically increase. The quest for solutions, both short and long term, both economical and environmental, is well underway. This is the story of one answer to the challenges that lie ahead. An answer that is not theoretical, but that is already in use. Since the Industrial Revolution, coal has been a major part of driving human progress. It is affordable, abundant, and reliable. Today, coal is used to produce half of the electricity generated in the U.S. It will remain an essential piece of the energy picture, along with solar, natural gas, nuclear, and wind, for many years to come. Since the 1920s, a process known as gasification has been used. It is in the front end of a process known as IGCC, Integrated Gasification Combined Cycle. IGCC delivers electricity from abundant supplies of a domestic resource while still meeting strict environmental standards. The process begins with coal entering the system mixed with water, creating a slurry that has the consistency of heavy oil. The slurry is injected into the gasifier along with oxygen, where it is heated to very high temperatures to produce synthesis gas, or syngas. The hot syngas is fed into the radiant syngas cooler. Heat from the gas is transferred to the high-pressure steam system for integration into the steam power production cycle of the plant. The syngas moves to the low-temperature gas cooling system, where more heat is extracted for useful work. The syngas passes through an activated carbon bed that removes mercury. Once it leaves this area, there are almost undetectable amounts of mercury. It then continues to the acid gas removal process, where hydrogen sulfide is separated from the syngas and later converted into elemental sulfur that can be used in chemical processing. Syngas, hydrogen and carbon monoxide, goes to a highly efficient and cleaner burning gas turbine combined cycle plant to create electricity. Excess high-pressure nitrogen from the air separation unit is used in the gas turbine as a diluent in the combustion process to reduce the formation of nitrogen oxides, a regulated pollutant that is known to create smog. A selective catalytic reduction, or SCR unit, integrated into the HRSG, further removes nitrous oxide formed in the combustion process to achieve ultra-low emissions. The hot exhaust gases create steam in the HRSG and is combined with steam from the SCR to drive a steam turbine generator to produce even more power from the plant that is sent to homes and businesses to power our world. The remaining gases are released from the stack in the HRSG, achieving levels of cleanliness not attainable by traditional coal plants. In the end, IGCC emits less pollutants than traditional pulverized coal plants. It also uses less water in the process, a commodity that is also more scarce in today's world. The system can also be designed for carbon capture and sequestration, wherein CO2, a greenhouse gas that would otherwise be emitted to the atmosphere, is captured prior to the combustion of the syngas and is injected deep into the earth into geologic formations, such as saline aquifers, for permanent storage. Here's how it works. The IGCC plant is modified to include a water gas shift reactor. and the acid gas removal system is expanded to remove the excess CO2. The syngas going into the water gas shift reactor is converted to hydrogen and CO2. The CO2 is removed from the fuel gas in the acid gas removal system. To be sequestered, it must be compressed into a high-pressure fluid and pumped to an underground storage facility. The CO2 will then be injected more than half a mile into the ground. Over a period of hundreds of years, the supercritical CO2 dissolves into the water and forms insoluble minerals. The technology for IGCC and carbon capture is here today. Around the globe, policy and regulatory support is needed for testing of large-scale storage technology to make that a reality. Tampa Electric Company's Polk Power Station went online in 1996. The plant has generated more electricity from cleaner-burning syngas than any other facility on Earth. It provides affordable, reliable power to millions in Florida and is confirmation of a cleaner coal future around the globe.
Coal is a valuable energy resource for the U.S. I've heard people say that clean coal is an oxymoron. I disagree with that. You can see a plant behind us here that's operating in a very clean way with cleaner coal technology. We use the latest state-of-the-art processes to remove the impurities from the fuel gas that's created from gasification, and we are extremely clean. It has been rated the cleanest coal-fired power plant in North America. The process that we have behind us here is a reliable process for power generation. Polk 1 was originally, from the Department of Energy's point of view, a technology demonstration platform. It's an integral part of our generation system. It's a technology that we've operated now for over a decade. It's actually the lowest incremental cost unit on our system. The gasification, that technology has been around for a long time. What's a little more recent is the combination of gasification, producing a gas from coal, and using it in a combustion turbine to produce power. And that's the combined cycle part of the IGCC process, integrated gasification combined cycle. "24 hours a day, 365 days a year, we are monitoring the emissions from the plant, and they're continuously low. We monitor the fuel for its constituent value, its heat input, its sulfur, its particulate matter. So those things are all prescribed by environmental regulations, and it's also a best practice to make sure the plant's operating properly. All coal, by its nature, has some mineral matter in it, essentially dirt that's left over from the mining process. And we actually turn that into a valuable byproduct. The mineral matter that leaves the bottom of the gasifier is sold to the cement industry. One of the other byproducts that we have is sulfur. And of course, our process here removes sulfur to a very high level. Once we have the sulfur, we actually create sulfuric acid, which is a beneficial byproduct. Here in Central Florida, there's a ready market for it with this phosphate mining and industry around here. So we sell that to the market, provides a revenue stream for us, and it's good for the environment in that fact that the sulfur is not landfilled or disposed of, it's beneficially reused. So there are many environmental advantages, and with IGCC, cleaner coal is a reality. The next plants will be even cleaner than we've demonstrated here. The technology will increase in size, become more efficient as a matter of scale, economies of scale, and then more work will be done also on the carbon capture and the greenhouse gas concern. So it does have a bright future. It's a real good fit with the energy profile and the energy resources here in the United States to be able to use coal and do so cleanly in an environmentally beneficial way.
In late 2007, plans for one of the world's largest commercial IGCC plants moved forward in Edwardsport, Indiana. State and local government figures combined with concerned citizens to create an energy plan that meets future needs with far less impact on the environment. How to provide the electricity that will be needed and do the best we can for the planet by working together to meet challenges created by a need for power, colliding with an environment with a need for care. Many solutions will be needed, But IGCC is not merely a concept for the future of coal-fired energy production. It is the now, and is the path forward to provide clean, affordable, reliable energy, and to ensure a bright future in the decades ahead.